Hello YouTubers, in this video I will be talking about the big O notation. In the previous lecture we have learned about the introduction to the data structures and algorithms. Now what does this big O notation means and why do we use it? The big O notation is one of the asymptotic notation. We use big O notation to find the tight upper bound of the given relation. Now what does this mean? To understand it, let us consider the graph, where x-axis represents the number of inputs and it increases from left to right, and the y-axis represents the rate of the growth and it increases from bottom to up. Now, you have an algorithm with an function fn and there is another function gn. Then, the gn is said to be an upper bound for fn after n naught. If and only if fn is less than equals to c into g of n, where c is greater than 0 and c is constant, and n it should be greater than n naught, and where n naught equals greater than equals to 1. Now to understand it better, let us consider the examples where fn equals to 2n and gn equals to 3n. Now, is this function a big of g of n? To consider it, we know that the fn should be less than equals to c into g of n, where c should be constant and n should be greater than equals to 1. So, 2 of n is less than equals to c into 3 of n. If we take c equals to 1, then n and n greater than equals to 1, then 2n is always less than equals to 3 of n. Therefore, this function f of n is big O of g of n. Now let us take the another example. Now the f of n equals to 3 of n and g of n equals to 2n. Now is this function a big O of g of n? It seems that like this, that 3n is never less than equals to 2n, but 3n should be less than equals to c into 2n, where now if we take c equals to 2, then and n greater than equals to 1, then 2n is less than equals to 4n. Therefore this function is also equals to big O of g of n. Now if we visualize this, the big O of n, big O, then what does this mean? The big O of g of n is the set of functions with the smaller or the same rate of the growth of g of n. For example, big O of n square includes big O of 1, big O of n, big O of 2 raised to power log n, etc. Now consider this example. Find the upper bound of n4 plus 10n square plus 54. Then the upper bound for this will be big O of n4 n raised to power 4 with c equals to 2 and n naught equals to 6. Thank you for watching. My next video will be about omega notation.